folks. Okay, so here's the long-awaited, just kind of getting started on the modeling assignment in ChemSketch and Chem3D. So sorry for the delay. And I got to tell you right now, I've graded these for a number of years, but haven't really done many. Just helped students while we're in the lab. Normally we do this in the lab, so we'll see how I fumble through this. Okay. So that's my email. Let's go ahead and we'll open up ChemSketch. Okay. It always, whenever you open it up, it gives you a whole bunch of stuff. Yeah, fine. This one, I say no because I don't want this to be my default chemistry drawing software. I have a different one that I like, this one over here. It's very expensive though, so better to stick with ChemSketch for class and everything. So I say no. It loves to give you tips, great tips, read them all carefully, I guess. Sure, okay, sounds good. All right, and so now there's two documents, obviously. We have, let's see. This is what tells us what to do, okay? And then occasionally through here, we're going to cut and then get this other document, which is our actual worksheet, and paste things into this one, okay? So we need two documents open, really, to do this guy. So let's see. All right, there's some good information about why three-dimensional structure of molecules is so important. Some great stuff in here, and there's also you can look up on Wikipedia the thalidomide story. That's a very simple but very dramatic example of why three-dimensional structure, and in that case specifically stereochemistry, is so important. It's such an important topic in organic chemistry, biochemistry, molecular biology, all those things. Anywho, okay, so I've got ChemSketch. All right, so the first thing I want to do is draw ethane in ACD ChemSketch and make sure that you are in the structure tab in the upper left corner rather than the draw tab. Okay, I think I will just read that document aloud rather than always show it to you guys. Okay, so what they're talking about here is this is the structure tab, this is the draw tab. Okay, so we want to make sure that we're in the structure tab, and it really sort of very easily, I mean, it wants to draw things, right? I can keep drawing. I could do all that kind of stuff. Okay. If you want to highlight any piece of this, you can either do it with lasso. The lasso, I guess, is cool. It's not my favorite. I prefer the other one where it's a box-like thing. Anyway, so let's draw ethane. Just 2-carbon molecule ethane. All right, beautiful. And then it says select the molecule using the lasso or the box. I said I prefer the box. Okay, I've selected it now. And now it says select 3D structure optimization from the tools menu. So up here, first clean structure. You see how my angle is a little funky and stuff like that. It's not as dramatic with ethane. If you draw a more complex molecule, you'll really see a dramatic difference. There, it makes it nice and clean. Let's select it again. How did I get back? Okay. Now come up to tools and go 3D structure optimization. And now it will sort of take your skeletal structure and draw out all those hydrogens and stuff. Now what I can do, so it says click on the structure and drag, 3D rotate is the default for 3D optimization. So what that's saying is when you do that 3D optimization, you can rotate this guy here. So if I just sit on one of these atoms, now I can spin this guy all around. Kind of cool, right? You remember thinking about your Newman projections? If I cite down the two carbons, what type of Newman projection that would be? What type of arrangement or conformer ethane is in right there? Hint, eclipsed. Okay, beautiful. All right, so now what does it want me to do? It would like me to open 3D Viewer using the toolbar, ACD Labs, or 3D Viewer from the ACD Labs pull down menu. That's what I'll do. ACD Labs right here, 3D Viewer. Pardon me. All right. Oh, so sorry. Okay, so now I've got that open. I can actually come down here. Let me maximize this dude for you. That's weird. Okay. Now, I will tell you right now that 3D Viewer, and I think it's just on my laptop, it acts really sluggishly. So when I try to do things in this 3D Viewer, it happens annoyingly slow. It's good enough for me to make this video, but I believe on other computers, it doesn't behave so slowly. You'll definitely see what I mean in just a second. Okay, so I'm going to go back to ChemSketch, all right? Return to ChemSketch, and then 2D copy to 3D Viewer. So if I come down here and I click this button right here, 2D copy to 3D, boom, it's going to send my ethane, whatever I drew, over into 3D Viewer. Okay, great. So super cool. There's a bunch of different types of styles you can do. Let's see. And so, yeah, the directions would like you to select the auto rotate and change styles. There's different styles you can do. You can have this be, this is ball and stick. You can do this one, where it's just sort of sticks, but you sort of see you see how slow everything's taking. I have no idea why it does that. I'm pretty sure it's just my computer. So that's just stick, but you can see the white where the hydrogens are. You can see the space. This is discs. This is space filling. I often tell students that these pictures that we draw don't do a very good job, actually, of accurately showing the volume of atoms and bonds, so that, you know, these torsional strains or steric strains might be hard to see with the drawings that we make when we make these, you know, line drawings of molecules in class and on our paper. But in reality, I always say reality molecules are much puffier. Okay, and space filling gives you an idea of that. And we'll just wait 10 minutes. Boom. That is probably a more realistic idea of what it. So now you can definitely get a better idea that things are much closer than they appear when you draw it with sticks. But you draw a complex molecule that looks like that, or you try to draw that, you know, especially if you're not a particularly good artist like me. If you're a bad artist like me, is the way I meant to say that, you're not going to be able to draw this. So we need the stick. You know, the lines and stuff that we use, but just sort of keeping in the back of our mind that atoms and molecules are more puffy. Okay, so if you click this one here, it will sort of toggle through all the different types of styles that you can represent your molecule, and it will also rotate this molecule. But because my computer is working so weird with 3D Viewer, it's just not even worth doing, to be honest with you. But you should try it on yours. Click that one, and it'll do all these styles, and it'll turn this guy all around. Okay, let's go back to ball and stick. We'll wait the requisite 10 minutes here. There we go. All right. Oh, okay, yeah, we can do labeling. So if we go up here to view, label all. Wait 10 minutes. Boom. Carbon, carbon, hydrogen, hydrogen, all that good stuff. Okay. All right. We can also rotate this guy by coming up here. These are going to be kind of two key buttons. This is 3D rotate, which is sort of like with the 3D rotate that we used in ChemSketch. And then this is, hey, when you want to point at a particular atom and tell the software, hey, this atom, buddy. All right, so let's look at 3D rotate real quick. And this is where the slowness of my computer gets really annoying, because I ought to be able to just drag this thing and show you all kinds of angles and stuff very fluidly. I can show you angles, but it's not fluid. Okay, so I will drag. I held the button down, and now it starts to turn. And so now you have to do it sort of trial and error. Is that the angle I want? I'm hoping that you guys don't have to do this. Oh, that didn't really do it. Oh, there we go. Okay, that's kind of what I was after. Is I wanted to look at something, sight down the two carbons again, much like we do when we draw a Newman projection. Okay. Pardon me. Sorry. Now we can do a 3D optimization. What that is basically calculations done by the software to decide. It will start, and this is a really oversimplification, but it will start twisting and turning and adjusting angles, and then evaluating, is that more stable than the previous arrangement? Okay. So it does sort of an iterative process in terms of trying to find the most stable conformation. Okay. Now, you've already covered in class. You should have an idea of what we expect the most stable conformation of ethane to be. Okay. Not this. Hint, hint. All right, so let's go up here to 3D optimization tools, 3D optimization, click it once, wait the 10 minutes, boom, that looks much better. Now you saw a dramatic change there. It went from eclipse to staggered. The directions, this was all put together by Dr. Horgan. He always recommends do a couple of them. And you do see a little, okay, so it made that adjustment. Now let's try it again. 3D optimization. And if you look real closely and you wait 10 minutes, and it's more dramatic actually with a more complex molecule like butane, or even when we get to cyclohexanes. Yeah, so do it a few times and then you're probably there. All right. All right, so we are actually ready to paste this. You want to be, we're going to paste this into our worksheet. You want to be sure that you're looking at it sighting down just as I am right here. You want to basically create that Newman projection vantage point. Okay. I mean, this is close enough. You don't have to, oh, wow. Okay, yeah. Now you can't even really see the other carbon in back. Okay, that's fine. Or if it's a little bit, a little bit off, that's fine. But just don't, don't have it turn totally the other way. We'd like to sight, that's a little, come on, let's go back. So annoying. I have uninstalled this software and reinstalled it. It's something with this laptop, I think. All right, now I've messed it up. Stop it. Oh, for the love of all of this. I'm actually going to get rid of the labels. View, label none. They're just distracting me. Okay. All right, there. I like it. Okay. Well, oh, my goodness. So sorry, folks. Again, this should, when you're doing yours, this should be much easier. It should be doing all this crazy delay stuff. You remember in ChemSketch how I was just dragging and it would twist the molecule all around and everything. All right, that's good. Don't move anymore, dude. Okay, copy, Control C and paste. So I can do Control C, or you can go edit up here and copy. Okay, and now we'll open our worksheet. Oops. Okay, here's our worksheet. I'm going to get rid of that box that says paste here. And then I'm just going to paste. Yeah, there's something. Okay, there we go. All right, beautiful. Now, before I forget about it, we're going to read through the directions. There's more stuff to do and make sure you do all that. But you're also going to come to this point, and it's going to ask you to draw an energy diagram for the different conformations of ethane. The software, this is not something you're going to get from the software. You need to hand draw this, actually. And you need to pay attention to, your values here. I don't know why this doesn't have a y-axis, but your y-axis should be kilojoules per mole. You might do it in kcals, but when I teach it in lecture, I teach it in kcals. And this information you should have already had in your lecture class. It's also in your textbook for the lecture class. It's also available through other resources. So anyway, software doesn't make this. You make this by hand. And do try to do a good job of getting the correct shape for your torsional angle here. So at 0 degrees, when your torsional angle is 0 degrees, what's that energy, et cetera, et cetera. Okay, let me move on now through the directions. Okay. Two handy things are these buttons up here. That select atom. That's 3D 3D rotate. Sorry, 3D rotate. Select atom. All right. Yeah, and sometimes you're going to need it. Like when we start doing bond angles and stuff, you're going to need this on atom select. A lot of the time when you hit this button, like an angle or a torsional angle and things like that, then it will automatically put it on atom select. Okay. And so now it wants me to, you can clear selection command. Sometimes it says the atom selection misbehaves. Not exactly sure. I haven't seen that misbehavior, but you can do clear selection command. Where's clear selection command? That's weird. Okay, I don't know where clear selection command is. If it's misbehaving, it also says that you can quit 3D viewer, return to ChemSketch, and open 3D viewer again. That's actually what I'm going to do right now. I'm going to click this up here, and I'm back in ChemSketch. Okay. All right. I'm actually, shucks. I'm going to go back to 3D viewer for the next part of the instructions. Maybe I shouldn't have canceled, got out of that, but at least you know how to do it now. And you can go back to it very easily. Come on. Go to ChemSketch, send this guy. Essentially, you're always in ChemSketch, sending it over to 3D viewer. Goes over to 3D viewer. All right, let's do our optimization a couple of times. Wait for it. Did it do it? That's weird. 3D optimization. There we go. That's a really good point there of why Dr. Horgan always says, hit the 3D optimization a few times, because, that first time it really didn't change it to staggered for some reason. Who knows? The number crunching just came out to some, it's probably what they call a local minimum. So anyway, demonstrates that it's good practice to do this 3D optimization a few times. Uh, Now we can see from a side angle even that we're in staggered, so we should be good to go. All right. Okay. All right. I'm going to rotate this guy so that we're looking at him in a little bit closer to Newman projection. Okay. When you do need to select atoms, and I'm going to need to select atoms now to do torsional angle, it is good to be able to see all the atoms. So I wouldn't want to put this totally in Newman projection so that I can't see that back atom. All right, so now it says do the torsional angle command. That's this little guy right here. All right, I'm going to click him. Okay. And then any torsional angle is defined by 4 contiguous atoms. Okay, so to mess around with a torsional angle like I'd like to do right now, I need to do click on 4 contiguous atoms. So I will click on that guy, and if you wait, he will turn green if I successfully did it. There we go. Probably much faster on your computers, I hope. If your computer does what mine is doing, you can get through this assignment. It's just a little annoying. I'm going to click on the third one, and I'm going to click on the last one. And when I click on that last one, once it recognizes it, it's going to bring up the angle. We expect that angle to be what? Don't look. 60. In a staggered conformation, it should be about 60 degrees. Now, in the directions, they want you to click these up and down buttons and actually watch this guy spin around like a top. Does not work very well with whatever my laptop is doing. So I'm going to adjust to these values that are recommended in the worksheet. Where is it? All right, let's try 0. Okay. Return. There we go. Let me, let's see, can I move you now? I don't know if it unselects everything. Okay, yeah, fine. Even when I click these buttons, there's a huge delay for some reason. All right, I'm going to move him just a little bit. Still need to see all those atoms. Oh, didn't want to do it that much. Oh, no. So sorry, folks. All right. Good enough. So you can see that that's kind of eclipsed. Let's do our torsional angle again. Should automatically put this on select atom. There it did. Just nice and delayed. Click H. Click C. Click C. Anytime now. Okay, see, it didn't get that, so I need to get back in there. Probably when you can see the carbon thing, that little text come up. Now I click. Wait 10 minutes, and there we go. Come up here, see the H, click on it, and my window shows up. All right. Let's try 120. Yeah, 120 is also going to be an eclipsed conformation, right? Oops. All right, let's do it again. This is much smoother when you can just scroll through things. It's really just, we're just trying to demonstrate how the torsional angle function works. There we go. All right, let's try 180. You can also do negatives. There we go, staggered again. All right. Reading through the directions. Yeah, now I want you to draw that curve that we talked about earlier, that energy diagram for the different conformers. Draw a curve, fit these different points of 0, 60, 120, 8, 180, etc., etc., and indicate the energy difference between the peaks and troughs, and label the points that are eclipsed and which are staggered. Okay, and again, you don't use this software particularly. You need to look it up in your textbook or some other source, the energy diagram for the conformations of ethane. Okay, what does it want me to do now? We're gonna draw butane. We're getting exciting here, guys. Hang on to your hats. Alrighty. Key. Let's delete that guy out. And let's draw butane. See, I drew it all sort of jacked up. I can come in here. I'm going to get that dude. No, I don't like the lasso. Now I can come up here to clean structure. Beautiful. I can come up here to 3D structure optimization. Does that. See, and this is the way it should work in 3D Viewer. You should be able to just spin it any which way. Kind of, it's kind of neat to be able to do this. It's really neat in 3D Viewer, but it's not working for me. Okay. So now we want to open again a 3D Viewer. Okay. And then we will go back to ChemSketch. It's kind of awkward, this progression, but it works. Copy, and then this 2D copy to 3D sends it over to 3D Viewer. Okay. And there we go. So now, okay, ball and stick. We're in ball and stick. That's great. Okay, so now we're going to do the same kind of thing with the torsional angle. Our torsional angle that we're going to deal with now is going to be the torsional angle defined by C1, 2, 3, 4, by the carbons, okay? Which is the angle that you normally adjust when you are doing a Newman projection, sighting down these two middle carbons. That's what we do with butane. That's what we always teach, to sort of introduce these concepts as we first do ethane, then we do butane, and do the Newman projection of butane, sighting down, pretending that your eyeball is about right here, looking down carbon 2 to carbon 3. Okay? All right. So now it would like us to take a look at the different angles. So we'll go up to torsional angle again. See, it needs to, yeah, okay. Now it changed. You got to wait till it changes to select atom mode, which happens automatically when you do torsional. All right, click. Click. When I do this torsional angle, what angle do you think it is right now? It's in a specific angle right now. Okay. That angle is 180 degrees roughly. Oh, shucks. You know what I didn't do? It doesn't really matter. I didn't do the 3D optimization, but we're going to be messing around with that anyway, so it doesn't matter. See? About 180 degrees. Let's set that to 0. For butane, that is the highest energy conformation. That is the completely eclipsed where the methyl groups are actually even eclipsing each other. Okay? So that will represent the highest one. And then we can look at the others. Let me remind you of how this is supposed to happen. Come on now. Okay, computer, take your time. Oh, I unselected it. Did I get that one? I did. Alrighty, there we go. Our window should have popped up. Oh shoot, we're not in torsional. Oh, you got to be kidding me. Are you going to unclear those? You sure are. Okay. Quirky software. Uh-huh. 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 And now we patiently wait. Do the last one. That should pop up our torsional angle window. Hi. Now, the way you ought to be able to do this, so this is either 0 or 360. It's the same, right? There's no difference. You just made a complete circle. It's decided to describe this as 360. I could set this back to 0 and you'd get the same thing. You should be, the way this should be able to operate is I can use these up arrows and down arrows, and literally, this angle will start spinning. You can see it happen very much in real time, very quickly. But obviously, there's something going on with this software on my laptop. Okay, so let's, I know a good one. Let's do this one real quick. 60 degrees. Okay. All right. That is a very particular, very important conformation for butane. That is staggered gauche, right? Okay, so let's see. Does it want us to copy and paste any of these things? Ah, yes. Use the torsional angle to put the molecule in gauche conformation. Orient the molecule from a Newman projection perspective. All right. So let's. It's in gauche. We did that successfully. Now I'm gonna move this guy a little bit so it's a better Newman. I mean, this is just trivial when the software and your laptop are working together. I mean, it's not a great... Oh, okay, that's a pretty good Newman right there. It also wants the with dots. With dots. Tries to also convey the puffiness. Is that with dots? Okay, yeah, with dots. It tries to keep the clarity of the ball and stick, but also convey the puffiness at the same time. Now it wants us to copy and paste this into our worksheet. You guys should be able to know how to do that by now. You just go Control-C and come over to your worksheet and throw it in there in the correct puka, that's the energy diagram for ethane, the energy diagram for butane, and this is where we would put it, okay? And then we also want to make an energy diagram for butane. And again, this is probably in your lecture PowerPoints or certainly your Smith textbook or available online. label your axes, label where staggered is, staggered anti, staggered gauche. You're eclipsed. Draw arrows that show, okay, the difference between this trough, a trough is a dip, and this peak, this mountain peak. The difference between these is, whatever it happens to be, 12 kilojoules per mole or something. Okay? All right, I'm going to stop here. There's one more thing I want to show you, but I got to do that in a second video. Later.